concept. The basic concept is that we have already discussed into our class that we have integers, right? And what do you understand by integers? So integers are basically to be known as whole numbers, right? Like for example, I can say that an integer is something like, right, like 10, 20, 30, 40, 50, 60, right? Like all of the numbers that are not in decimal, only numbers that are in whole numbers. That is, and that is not in decimals, right? Like if it's 4.66 or 6.8 or something, that means that it is not a whole number. A whole number is the one that that is a complete number without any decimal. So one thing here is to be known that whenever there is an integer, that means I have two numbers that are either positive or that are either negative. So I have two types of integers, either positive or either negative. So if it is a positive integer, that would mean that either if this is 80, either if this is 90, or either if this is 100. And the point is that basically we can convert these denary numbers even into the binary as well, depending. I can convert these denary numbers into binary, and this is what you understand it. We have done that into our last lecture, that is the conversion of it, right? Are you getting the point?
Yes, sir.
But we have not discussed that if you have a number that is minus 70, if you have a number that is minus 45, or if you have a number that is minus 20, we have not discussed that how we are going to convert these. This is what we are going to discuss in today's class, that for example, if you have negative terms and if you basically wish to convert them, so what procedure you are going to use? There are, the name of the procedure is two, right? Like there are two ways for using them. The first way is going to be your ones complement, and the second technique that I can use to convert them is to be known as two's complement. So I have two areas for that. So starting with the first version, that is a ones complement itself. We are going to discuss this technique in detail. So ones complement is basically like if you are just flipping all the bits. Like for example, if you have a 1, it is turned into 0. If you have a 0, it is turned into 1, right? So for example, if you have a number into a question, and that is that you need to apply ones complement, on 100 1001. So for the solution of this question, what you are simply going to do is you are going to copy paste the question right here, which is 100 1001, and then what you are going to do is that you are going to flip each one in terms of 0 and each 0 in terms of 1. So 1 becomes 0, 0 becomes 1, 0 becomes 1, and 1 becomes 0, and 0 becomes 1, 0 becomes 1, and 1 becomes 0, right? So is this clear?
Clear, sir.
So like, right, like for example, if it's 1 0 0 0 0 0 1 2 3 4 5 6 7 8. So what I'm going to do for the ones complement part is that I'm just going to flip it. So 1 becomes 0, the rest of them becomes 1. So this is simple. That means that I'm just flipping the number of the bits. Other than that, the second area that we have to discuss is going to be your twos complement. So if I'm discussing with you in terms of a two's complement, so what really happens is that you have basically a series of numbers, and that series of numbers is like 1, 2, 4, 8, 16, 32, 64, and minus 128. We need to discuss right here that I use the number minus 128. Why I'm using this minus 128? This is supposed to be the positive number, but you need to understand it that I'm using this minus. The reason is that so that I can generate a binary value of I can generate a binary value of negative integers. So this is why this is the reason that we take the minus 128 in 2's complement. So for example, if you have a question, right? A question, right? Like for example, using 2's complement, calculate the binary equivalent of minus 95. So if it's a question like this, that means that now you have a negative term. The negative term is minus 95. And what you wish to do is that you wish to convert this minus 95 into a positive number. No, not a positive. You need to convert this minus 95 into the binary equivalent. So what you are going to do is that you are going to take these series, that is 1, 2, 4, 8, 16, 32, 64 minus 128. This is the method for your 2's complement. And now what I need to generate here is minus 125. So for generating a minus 125, the first thing you need to have into your answer. Now, wait. What you need to do right here is that you need to add a sum of numbers that equals to minus 95. So for example, the first thing that I'm going to do right here is that I'm going to turn this on, which means that minus 128 should be a part of your calculation. Now what you need to add here is those values that if I add them together, they result in minus 95. So I'm going to check one by one that if I have a minus 128 and if I add minus 128 plus 64, what I'm going to get? The answer is going to be 64. So that means that I'm not going to take this because the answer is less than that, and I'm not going to achieve my answer if I select this. Other than that, I am going to have minus 128 plus 32. Minus 128 plus 32 is equals to uh 96. 96. That means that right now I have 96, but the answer that I need to achieve is 95. So if the number is greater than that, that means that I do have the ability to deduct the number. So this can be right like 0, 0, 0, 0, and 1. So minus 128 plus 32 plus 1 results in minus 95, and at the same time, your final answer that is going to be generated is of 1, 0, 1, 0, and 0, 0, 1010 and 0001. This is going to be your final answer of a negative number. So do you have any confusions in this?
No, sir.
This is your method 1. However, to solve this question, you have another method as well. So for your method 2, for example, if you want to calculate a binary equivalent of minus 95, so perhaps what you're going to do first of all is that you are going to generate a positive positive 95 and ignore the negative part, and ignore the negative part. Just after that, what you need to do is that you need to apply one's complement on that, and then what you need to do is that you need to add a 1 of binary addition into the answer, and that is going to generate your final answer. So let's work on this. These are the number of steps for your method two. The first step says that I need to generate a positive 95 and I need to ignore the negative part. So for that, I'm going to use the same series. It's going to be 1, 2, 4, 8, 16, 82, 64, 128. And right now, what I wish to have right here is a positive number of 95. So 128 is obviously greater than 95. So I'm not going to take that. This is going to be 0 and this is going to be 1. So 64 plus 32 is basically 96. So 96, it's a number greater than that. I need 95. So I'm not going to take that. But 64, if 64 is added to 16, this results in 80. That means that I need 10 more. Wait, I need 15 more, right? So 80 and 8. 88, 89, 90, 91, 92, 93, 94, and 95. So this is basically a positive 95 binary equivalent. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 0, 1, 0. Okay. Just after that, what you need to do is you need to apply one's complement on this answer. And if I apply one's complement right here, so the answer is going to be like 1, 0, 1, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Now, the third part says that you need to add 1. So I'm going to copy it right here. 1, 0, 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to add a 1 here. So this is going to be 1 and 0 is going to be 1, 0, 0, 0, 0, 1, 0, 1. This is my final answer of the negative 95. So let's check that if the answer is correct or not. The answer through this method is supposed to be 1, 0, 1, 0, 0, 0, 0, 1. And with the help of method 2, the answer is same. So with both of the methods, the answer is same. Do you understand it?
Yes.
Apart from this, right here, I added 1, but this 1 is of binary addition, and this is basically another topic that we need to discuss in today's class, right? So, any confusion so far?
No, sir.
So now let's discuss binary addition. So, what do you think? 1 and 1 is equals to 2? Like, if I ask you what is 1 and 1, if I add 1 and 1, what is the answer?
2.
I say that 1 and 1 is equals to 10, or I can say that 1 and 1 is equals to 0 with carry 1. Is this, do it make some sense?
No.
No. Can you prove it? Can you prove it?
How am I supposed to prove it?
And what if I say that I can prove it that 1 plus 1 is equals to 0 with carry 1 or 10? So should I prove it? 1 plus 1 is equals to 0 with carry 1.
Yes.
Now listen closely. If I add 1 and 1, what it results?
2.
But you cannot write 2 here because you are working with binary, and binary has only two numbers, either 0, either 1. So what you are supposed to write here, you cannot write 2. 2 is going to be wrong. You cannot write here. The answer can only be 0 and 1. Now, which is the language that I use in daily life?
Then it.
So if I add 1 and 1 together, what is the answer in
2.
everyday life?
Every life 2.
2. Now, can you convert this 2 into binary?
Yes.
1, 2, 4, 8. I'm not writing the whole of it because I just need this area. So this is supposed to be 0, 0, 1, 0. What is the answer
Mm.
right here? If I've converted the 2 of denary into binary, this is 10 or this is 0 with carry 1. So for example, if 1 is added to 1 in binary addition, you cannot write 2. You need to write 0 with 1. And if it's 1 and 1 in denary, you can easily write 2 because you have the power to do so. But you cannot do it in binary addition because you can only write 0 or either ones. So are you getting the concept?
Yes.
So is it proved now that 1 and 1 is equals to 0 with carry 1 or 10?
Yes.
So let's say if I have 1 plus 0, so this is still going to be 1. And if I have 0 plus 1, it's still going to be 1. But what do you think? If I have 1, 1, and 1, if I add these, what is going to be the answer in denary?
3.
3. But what is going to be the answer in binary? I cannot write 3. That means that I need to convert this denary into
Binary.
binary. So what I'm going to do is right here, I'm just going to add a 1 here. So the answer is 111 is basically to be known as 1 with carry 1.
Sir, can we write 0011, or should we only write 1 with
You
carry
can
1?
write it, but they are not considered. We only consider the value that is starting from the 1.
Okay.
Even if you write, it won't impact you. So these are basically some rules for your binary addition. So let's say if I ask you to add a number of values, for example, if it's 1, 0, 1, 1, 0, 0, 1, 1, and 1, 0, 1, 0, 0, 1, 0, 1. So what are we going to do?
Add them.
For example, the first one starting from here, 0 and 1 is considered as
1.
1 and 0 is considered as 0 and 1 is considered as 1 and 0 is
1.
considered as 1 and 1 is considered as 0 with carry 1, and then 1 1 1 is considered as 1 with carry 1, then again 1 and 0 is considered as 1 and 1. So this is your answer. Are you getting the concept?
Yes.
Now for example, if this is a question, how are you going to solve it? Can you just tell me the final answer for this?
Yes.
The answer is, should I tell you the answer?
Just a second. Yes, can you tell me the answer now?
G.
Can you tell me the answer now?
Yes. 1 0 is 1, 1 1 is 0 with carry 1, Then again 1 1 is 0 with carry 1. Then again 1 1 1 is 1 with carry 1. 1 1 is 0 with carry 1. 1 1 1 is 1 with carry 1. 1 1 is 0 with carry 1. 1 1 is 1 with carry 1. Do you have the same answer?
Yes.